Welcome, everyone. It's my pleasure to welcome you to the Earth Observations in Support of Climate and Environmental Security mini-symposium. I am Anna Mikulak. I'm the director of the Department of Global Ecology at the Carnegie Institution for Science and a professor in Earth System Science at Stanford University. I'm also a member of a study group that is organizing this mini-symposium, and I have the pleasure of introducing the symposium this morning. And so this virtual mini-symposium is being co-sponsored by the JPL Center for Climate Sciences and by the Keck Institute for Space Sciences in conjunction with an ongoing study on the topic of developing a continuity framework for satellite observations of climate. We have a series of great speakers whom I'll introduce at the end of my introduction, and then we'll have a discussion after those presentations. And so, of course, as context, I think we all know why we're here. As a result of human activity, we are changing the Earth's climate at a pace that has not been observed in recorded history. And I realize this slide is very familiar to everyone, with years on the horizontal axis and temperatures on the y-axis. But I always like to remind myself, as well as everyone else, that when we talk about targets along the lines of, let's say, 1.5 degrees centigrade or 2 degrees centigrade, it's important to remember that we're already past the 1 degree mark. And so really, we're not talking about an additional 1.5 or 2 degrees. We're talking about a total change, and we're dangerously close to that already. For the purposes of today's discussion, we're not just talking, of course, about temperatures. We're really talking about how climate change is impacting almost every aspect of human activity, but also ecosystems. And so really it comes down to how resilient are species, communities, and ecosystems to global change. And I really like this figure that was taken from the AR5 IPCC report from 2014, where you can see, even just for North America, all of the different observed impacts that have been directly attributed to climate change, where all of the filled symbols are those where there has already been a substantial impact on anything ranging from, of course, snowpack, but all the way to things like livelihood, health, and economics. And then the bars on the side give you a measure of how confident scientifically we are in terms of the attribution of the change to climate. Just to get a little bit more specific, I realize this is a very busy slide, so I'll just zoom you in on a couple of numbers here. So this is from the latest summary for policymakers from the IPCC that was released just last year. And what you see here are regions where we expect substantial impacts on different aspects of the climate system. So for example, this first red box is showing you that in almost all regions across the world, we of course will see, and are seeing already, large impacts to mean surface temperature and to things like extreme heat. In a very large fraction of total regions, which is this lighter bar in the back, we're seeing already increased heavy precipitation and pluvial floods. And then the third one that I'll highlight here, for reasons that will become clear in just a minute, is huge changes to relative sea level, coastal flooding, and coastal erosion. And as far as this figure is concerned, and the summary for policymakers is concerned, here we're talking still just about impacts to the physical system within which we live. But this is, of course, then linked to all of the types of security issues that we'll be talking about today. And so in the same year, so this is last year that the IPCC released this summary for policymakers, there was a national intelligence estimate that was released on climate change and international responses that are increasing challenges to US national security through 2040. And in that report from the National Intelligence Council, there was a table that, if you look back at the figurehead here, had many of the same themes, but also, I need to move my speaker view here, there we go, talked about the impacts to human security that result from these changes, both current and anticipated, to the physical climate system. So for example, if we go back to the first example I gave you, which is essentially heat, we're expecting, of course, more intense and frequent heat waves. And these are not just physical impacts, but they are expected to reduce labor productivity, increased frequency and intensity of wildfires, undermine human health, and lead to loss of life. If we go to the second example that I used, which was the example of heavy precipitation and flooding, increased flooding will lead to economic losses, increased calls for humanitarian assistance, and loss of life. And the third example I used, which was sea level rise, will of course increasingly imperil coastal cities and exacerbate storm surges, the damage infrastructure, and inundate water systems. So I'm giving you the examples just to show you the very direct link between the changes to the physical climate system and security of a variety of aspects of human activity. Where the study that is co-sponsoring this symposium comes in is the realization that the chain from data to usable climate information has gaps, and this is impeding effective management and decision support. And so the first gap is that sustained observations of the Earth system in support of climate change science, projections, and decision support is currently not guaranteed. And then the second challenge is the dissemination of that information to provide access and usable information for both science and for decision support. And out of this need, this study that I mentioned at the outset was conceived. And so the name of the study that I am a member of the study team for, and others who are here as well, is on developing a continuity framework for satellite observations of climate. And so to read a little bit from the study summary, the goal of the program is to help accelerate discussions and plans for greater and more impactful US contribution to the global climate observing system in support of the needs that I mentioned on the previous slide. And I won't read through the rest of the text here, but we could go back to it later as needed. To give you a sense of where we are with the study, this is the third of these mini symposia. There was two this summer. The first was on the US and International Earth Observation from Space Program of Record. The second was on commercial capabilities, plans, and opportunities that impact POR and plans on continuity. And this is now, of course, the third such study. The study team itself has met for 1 week-long workshop, meetings in the interim, and we're actually meeting for a second week-long workshop next week with a goal of coming up with a report summarizing our main conclusions and recommendations in the coming months. And this symposium that we're holding today will help inform that work. As I mentioned, this is the third of the 3 mini symposia that we have held in support of the study. And today we will have 3 speakers: Rod Schnonover, Aaron Sikorsky, and Edward Carr, and I will introduce them briefly before their remarks. But before I do so, I wanted to pause for a second and ask whether any of the 3 co-leads of the study wanted to add anything after my introduction and before we jump into the presentations.
And I think you did a beautiful job, absolutely. And we look forward to having this report out and these sets of recommendations out in the early part of 2023. And we're hoping that this is just the beginning, really, of more significant conversations about the planning of the climate observing system. So
wonderful. Thank you. Thank you, Betsy. And it looks like Dwayne Wallace is speaking as well, but I think you were muted, Dwayne.
Okay, yeah, I'd just like to echo how well you just set that up, and also add on behalf of the study team, give a shout out and thanks to Apurva Dave from the National Academies. Apurva is one of the staff officers that is responsible for the Climate Security Roundtable that they recently set up, and he was responsible for really helping us set up discussions with a number of climate experts and helped us get on our way to identifying the 3 speakers we have today. So thank you, Apurva. That's it from me.
Wonderful. So I will stop sharing my screen now so that the first speaker can start sharing his. And in the meantime, if I can get my screens figured out, I will give a very brief introduction. And so our first speaker is Rod Schnonover. He is an internationally recognized expert on global ecological disruption and climate change and their impacts on people and on societies. He has held a variety of senior roles in the US intelligence community, both at the National Intelligence Council and at the State Department. He is also a senior fellow at the Council on Strategic Risks, a senior associate at the Center for Strategic and International Studies and adjunct professor in the School of Foreign Service at Georgetown University. Dr. Schnonover was a four-time recipient of the State Department's Superior Honor Award and received several awards for excellence in analysis from the Office of the Director of National Intelligence. In 2015, Dr. Schnonover was awarded the State Department's Bureau of Intelligence and Research Analyst of the Year, which is its highest award for outstanding analysis of scientific and environmental issues with significant impact on U.S. national security and foreign policy. And prior to his government service, Dr. Schnonover was a tenured professor of chemistry and biochemistry at Cal Poly in San Luis Obispo. And with that, Rod, I'll hand things over to you, and we look forward to your presentation.
Okay, let me make sure I'm sharing the right thing here. How's that?
I can see your questions to ponder slide.
Okay, awesome. Well, thank you to the Keck Institute. Thanks for the organizers of the symposium. I'm really pleased to join my other panelists who I know pretty well and think highly of. And I very often talk to both security and science audiences on topics of climate and ecological disruption. And so this, I'm going back to the title of this, the symposium to talk about both climate and environmental security. And I usually don't use the word environmental in much of my language. I usually use ecological. But just some questions to ponder when I give a talk like this to a general audience that isn't all well versed in security. And it's really how to assess risk from ongoing climate and ecological disruption. And what is it really, what do we mean by security? As an example, this is something that I watched in while I was in the intelligence community. This is what I would call an ecological security event in which a massive harmful algal bloom of red tide, which emits this really toxic compound, saxitoxin, created one of the most significant ecological events in Chilean history. It had massive effects on the fishing industry and also the labor, the labor institutions and people who were dependent on fish. And in fact, it led to a significant amount of unrest. In fact, the fishers in this area created a blockade, a maritime blockade, and this lasted for many weeks. But it had this ecological input, the stress that came from, well, a lot of people wanted to blame climate change right off the bat, but it turned out that it was improper dumping of dead salmon that fueled this. But this is just an example of, really what I talked about as ecological disruption. And so for me, comes in two pieces: ecological degradation. This is also climate instability, but also things like pollinators and logging and water stress and agricultural stress, in addition to the new harms that are increasingly emerging from rapidly changing planetary conditions, the conditions, the rapidity that Anna mentioned at the very beginning. There are some organisms on the Earth who are predisposed to take advantage, and some processes as well. And so I like to bring up these kinds of issues because we often talk about ecological degradation exclusively and if we do that, I don't think we scope the problem correctly. One of the biggest threats to food security in the last 5-6 years were these transboundary massive locust swarms who had very pronounced effects on food in not just in East Africa, but also in Middle East, South Asia. I have a picture of coronavirus, SARS-CoV-2. I think one of the things that we often don't talk about or enough, especially in this climate security, ecological security world that I and the other panelists occupy. We don't really talk as much as we probably ought to on the biotic channels by which ecological and climate disruption act on people. And so I have a coronavirus picture there, but also I think antimicrobial resistance, antibiotic resistance is another issue in addition to swarms of harmful organisms. And if I mention ecological security, this is what I mean, the human, national, or global security outcomes that arise from ecological disruption. And here's really the analytic roadmap, and it's overly simple because the actual roadmap or workflow, thought flow is way more complicated than this. But I think it's important just to mention from the outset and to not forget that Earth system conditions are changing, they're dynamic, the climate, there are the other pieces of the Earth system that are changing as well. But so are the social and political and informational conditions and other things that also amalgamate to create human and social stress. And from human and social stress, you can, some subset of that may create conditions for risk to human security, national security, and also global security. These relationships are typically messy and bidirectional, and direct causality is uncommon. That hasn't stopped the academic community from looking for those direct causal linkages, however. So in the intelligence community, one of the roles is to produce strategic warning, and part of that is really analyzing the risk from ongoing and future ecological and climate disruption. And this is a very well-known formula in terms of risk. And so I think one thing that separates the security community from the scientific community is the degree to which risk is put front and center. Both communities deal with it, but I think the security community thinks more about, or at least talks more about risk than the scientific community. So there's the stress part, which is also hazards, but you also have exposure and vulnerability. And really analyzing the risk comes from at least 3 of these. And these 3 may not be generated by the same communities. So for example, in climate change, climate hazards may come from Earth observations of biophysical parameters. But exposure and vulnerability may be coming from, if it comes at all, from different communities who gauge things like GDP and inequity and other kinds of things that may not have direct observables, or we may have proxies still. If we believe that climate and ecological disruption is serious, and all 3 of us on the panel, I think, believe this, then it is imperative to really assess risk by looking at all 3 of these parameters. However, there's a persistent tendency for us to really only look at the hazard part and downplay the exposure and vulnerability. You do not have to have increasing incidence of hazards to have increasing risk because of those 2 other elements. Likewise, there's a persistent tendency for analysts and policymakers to focus primarily on the stresses and hazards and not on the other pieces. And so just about scoping risk, one of the questions is how are we scoping risk, and are we doing it right? And just beginning with a sub-focused on climate change, right? So when I say a sub-focus, because I generally talk about climate disruption as a bigger part of, or as a part of a bigger ecological disruption. So, but do the typical indicators of climate risk capture the true climate risk? That would be an important question. And then, are the climate stressors or hazards being considered in risk assessments, say by the intelligence community? Are they adequate? And so the other question that I won't address, but I'll just leave it hanging out here: what do we miss when we don't consider purportedly low probability events in our risk analysis, in our security risk analysis? This is a picture that I usually show to non-scientific audiences to really explain climate change and why it's such a pervasive problem. Anna hit a lot of this at the beginning, but I almost never talk about climate change as an environmental issue, partly because the word environmental inside the security community doesn't land with the kind of force you might expect. If you talk about an environmental issue to someone, say, at the Department of Defense, they may not see that as in their, they may see it as an important issue. They may not see it as their issue. But, if we talk about temperature, not just as an environmental variable, but as a planetary control variable that changes anything that is temperature dependent, or at least potentially changes anything that is physical, chemical, biological, ecological, agricultural, industrial, etc. All of those processes have the potential to be moved by temperature. And it's probably not a good practice to assume a lot of that will cancel out. It's almost certainly true that a lot of this will amalgamate into worse outcomes for people and societies. And there's a parallel argument about pH in the oceans. It doesn't have the same centrality for all the other Earth systems, but it's still quite a problem in the marine systems, as many people on this call work on and know. And so I think everyone on the call knows about these. Again, I show this to non-scientific audiences, but I think it's important. This harkens back again to the chart that Anna showed on impacts and resilience. So these are some climate trends. We know these with differing confidence levels. I think from a risk perspective, that if it's in terms of if it's even, let's say 50-50 confidence level, it should be put into the risk assessment. It should be thought about at least. And each of these entries has a security dimension, but really I think it's the aggregate that is possibly more important than the individual entries. And I'm not going to talk about any of these, but they are all important, with some of them with profound security implications. But those are the biophysical parts. How do they affect people? So to get to security, you have to go through people. And so impacts from extreme events, single and multiple crop yields, human and animal health. And the overwhelmingness of this is somewhat the point in really, I think, in appropriately scoping the risk from climate change. And so this is a paper that came out 2018 in terms of really, are we scoping the risk from climate correctly? And so when we have the national intelligence estimate that Anna mentioned, that considered 6 climate hazards. I think, or 8 of them. I think 6 of them were abiotic in nature. This paper argues for 467 pathways. That's a lot to take in. It's probably overwhelming for risk analysis. But by, I think by widening the aperture, I think we can actually better address the seriousness of the problem. And I often talk about, if you don't scope the problem appropriately, you don't get to the right policy solutions. And so back to those questions, do the typical indicators of climate risk capture the true climate risk? So most analyses that I have seen, and I read as many as I can, most analyses of climate change and their security implications focus on a small subset of what I call meteorological factors. Probably abiotic is a better term. And it makes sense why we focus on those, because we know those with better precision. For example, sea level rise trajectories are, there's uncertainty, but very well known in terms of the trends. But the biotic factors, I think, are almost never taken into account. For example, higher risk of infectious diseases and things like that. And then also people and societies will increasingly experience risks in compound, either concurrently or consecutively. And humanity struggles with really assessing those kinds of risks. I would say that this kind of analysis is very nascent, especially in the climate security world. And then the second question, are the climate stressors and hazards being considered in risk assessment adequate? And I say, no, not really. If these stresses, and this is just my take, remain unaddressed or underaddressed in national security, then it's increasingly mismatched to the threat landscape that, say, the intelligence community is supposed to track. And so getting the threat landscape correct, I think, is important. It's hard. But I think focusing on the same 5 or 6 variables will lead us to a serious underscoping of risk. And I said, just focusing on a subtopic of climate change. Well, here are some other things happening in terms of biosphere instability, biodiversity loss, biosphere redistribution, pollution and plastics, almost never talked about in a security context. Nutrient overabundance, invasive species, overexploitation. And these are only the Earth system conditions that are changing, right? Those other social, political, informational, et cetera, conditions, economic conditions are also changing. And so, but unfortunately, I think currently the policy security communities are prone to so-called carbon tunnel vision. And this adapted from someone else, but basically, as we're looking at Earth system changes, focusing on greenhouse gas emissions and focusing on a narrow set of climate hazards, I think leads us into potential danger in terms of, again, scoping the risk. And this is a paper that came out a couple years ago actually, I guess it's not almost 2 years ago. As a former academic who used to write papers, the title of this that went through peer review, I think is just kind of incredible, underestimating the challenges of avoiding a ghastly future. But basically, the idea is that this paper brings up the climate challenge, but it brings up the biodiversity challenge as well, and it brings up consumption as well. And I think it's a rather interesting article in terms of really trying to set the tone of the challenge. I would say that over the years, I've seen, I've read articles on climate change over, 30 years. I would say that the tone in the ecological sciences community is becoming even, in my opinion, probably even more dire than what I see in the other Earth systems. So how might we think about the effects of ecological disruption? Not just the climate part, but these Earth system stressors. To get to security outcome, you go through human and social stress. But in this slide, I've added this term, ecosystem services. I think most people on this call must be familiar with. I will say that security community is practically ignorant of the concept. Not completely, but close. Basically, a lot of these arrows, these pathways are really unknown. What does it mean for pollinators to go away? What does that mean for things like political instability? What does it mean for an invasive species problem to be hyperfueled by climate change? What effect will this have on ecosystem services and things like food and disease? And so really a really full-blown research agenda on getting at almost all of these arrows is greatly needed. But more relevant to the topic of this symposium, how might Earth observations aid a general understanding of perturbations in ecosystem services and their effects on human and social stress? And these are the ecosystem services that the IPBES, or as I call it, IPBES, enumerate. Some of these are material, some of these are services, some of these are non-material. I think if you think about degradation in these ecosystem services, you can imagine security outcomes for practically every one of these. And so, unfortunately, as I just said, we don't really understand, for example, declines in seed dispersal or declines in air quality and its effects on, say, cognition. We don't know how those kinds of things manifest as societal insecurity outcomes. And I could just talk for a long time on this slide, but let me keep going. To security. What does we mean by security? And so if you just go back to its basic form, it's prevention, reduction, and resilience to harm. And then when we're thinking about national security, must we consider an actor, right? Can we have actorless national security threats? And this is one of the problems historically, I think, why climate change has had difficulty being embraced by the national security community, not just here in the United States, but internationally. It's because the national security doctrine and architecture practically requires an actor or a proximate actor. So who do we point the drones at? Who do we point the microphones at? Which actor do we go through psychological analysis and all of those things. Are we, can the national security communities conceptualize threats such as climate change as the threat itself, right? And so I think one of the difficulties of dealing with COVID was the coronavirus is not an actor, even though a lot of people were hoping that there was some malign actor. Not hoping is not the right word. We're looking for a malign actor to better conceptualize that. I'm going to leave that question on the table here, but I think it's, if we're looking at the evolution of national security, which is underway, it is really, I think, a big piece of this, embracing so-called actorless national security threats into that doctrine. And so just the last pieces of this are pathways of risk to security. And so just, I'm not going to go through any of these in depth, but this is something I made for myself when I was in the intelligence community and thinking about how different ecological or climate stresses, how they might manifest themselves as security outcomes. And so you can have death or injury from direct harm. This is human security, so human focused. Water stress, food stress, erosion of economic livelihoods and labor, loss of residence or property through wildfire or extreme events, effects on human health and well-being, infectious diseases, mental health, etc. Negative impacts on education, especially girls' education, intensified violence or crime, like conflict over land and water or fish. And this isn't meant to be exhaustive, it's just illustrative. Pathways of risk to national security, okay, harm to citizens. So for us, US citizens here at home or abroad, the one I think about probably more than anything else is political and social instability in terms of unrest and conflict and fragility. Also important impediments to recovery. So there's an important connection here between the human security slides and national security in terms of how grievance and inequity and pre-existing conflict can lead to or contribute to political and social instability. This is a map from Fund for Peace, the Fragile States Index. The United States way of international and domestic engagement is works best when more of these countries are in the blue and green. When there are atmospheres of, or when there are instances of conflict and instability, things like corruption, threats to the rule of law, even disease, are more probable. And so it would be good to keep more countries off of this list, and it would be good to be able to bring some of those back into the blue and green. Other pathways, heightened tensions over resources, especially shared resources, negative impacts on key economic sectors like insurance or tourism, etc. Adverse effects on militaries. Finally, I got to talk about the military. I don't equate military security or what the Department of Defense is focused on necessarily as being exhaustive or equivalent to national security. There are important non-military pieces of national security. Changing or emergent geostrategic domains. We talk a lot about the Arctic, but there are other domains as well. Effects on global systems and resources, especially economic systems, effects on global supply chains, something the Department of Defense cares a lot about. Loss of territory, the age-old reason for conflict, altered patterns of disease outbreaks, especially things that contribute to pandemics or antimicrobial resistance, changes in large-scale or especially unmanageable migration, impacts on insurgency, conditions favorable to insurgent or terrorist recruitment, intensified hostility to here, the United States. All of these would be what traditional national security officials and experts would see as national security risks. So back to addressing risk from ongoing and future ecological disruption. The stress, the exposure, vulnerability, we have such a limited understanding of these risks in terms of compounding and cascading and surprises and all kinds of ecological stresses that don't fit well into a system of partial differential equations or whose data is really sparse to begin with. And so there's a lot we don't know. But borrowing from the environmental community, who in Rio 1992 articulated a version of it that I think is quite a good one. The lack of full scientific uncertainty, or lack of full scientific certainty, shall not be used as a reason for postponing action. And I actually think that there is a precautionary principle for security. Shouldn't we must we wait until all of the scientific components come in, especially in that risk equation, when considering the linkages between ecological disruption and security? Isn't there a mandate to act? And this is really the argument I make for the security community, that getting more studies between climate and violence, for example, should not postpone actually reducing vulnerability and exposure to climate change. And that's it for me. Thank you. I'm really pleased to have been to be here and look forward to questions from the audience. Thank you.
Thank you, Rod. I think it's fair to say this was an incredibly informative and interesting presentation, although perhaps not uplifting.
Yeah.
given the topic. Dwayne, were you waving or raising your hand?
I was trying to wave. I was trying to hand clap, actually.
Perfect. Okay, I believe, Tim, correct me if I'm wrong, but we will leave the Q&A for the discussion at the end, correct?
Yes, that's my plan. I'm trying to take some notes here and then give some guidance on the Q&A process following our other two panelists.
Wonderful, perfect. And so let me go ahead and introduce our next speaker, who is Erin Sikorski. She is the director of the Center for Climate and Security, as well as the director of the International Military Council on Climate and Security. In addition, she is the founding chair of the Climate Security Advisory Council, which is a congressionally mandated group designed to facilitate coordination between the intelligence community and U.S. government scientific agencies. Ms. Sikorski is an adjunct professor at George Mason University, a visiting fellow at the University of Pennsylvania's Perry Worldhouse, and serves on the advisory board of the Smith College Center for Environment, Ecological Design, and Sustainability. Today she'll be telling us about climate change and national security. Over to you, Erin.
Great. Thank you so much, Anna, and thanks to the Keck Center for hosting this. Very pleased always to speak anywhere with Rod Schoonover, and I am a big fan of Dr. Carr's work as well. So I have some slides. Am I able to advance them, or am I going to have to tell you to advance them, Wingsy?
If you are sharing your screen, Erin, then you can advance it. If Wingji is sharing her screen, then you'll have to let her know.
Okay. Yeah. Okay. Yeah. Wingji is sharing her screen, so
okay.
I'll have to have her advance it. What I'm hoping to do in my remarks, there are a few things today. I'm going to build on the foundation that Rod has laid. I'm going to speak a little bit about how I think about the national security risks posed by climate change writ large, and then give a few specific examples from different regions of the world, because I think that really helps ground the conversation, what we're talking about. And I think it will also help as we talk about the Earth observation piece with some concrete ideas of the kinds of things and kind of issues that we're looking at. And then I'll end by talking about just broadly some thoughts on both challenges and opportunities related to bringing Earth observation science and the national security community together. So thankful that you're doing this. One of our key points at the Center for Climate and Security where I work is we need to build stronger bridges between the national security community and the U.S. Scientific community, both within and without government. And so efforts like this, I think, are really important to national security writ large, both so the national security practitioners can learn from the scientific community, but also so that the learning can go the other way and that we're all speaking the same language and can work together to both tackle the risks from climate change and tackle the national security risks that are from there. So next slide, please. So both Anna and Rod have already given a very good overview of the science, right, and the hazards and what we're concerned about in the national security community. I wanted to highlight a few things, though, why I think these climate hazards are so challenging for national security. And beyond just the direct impacts, it's the challenge that climate change is posing to planning assumptions, right? And this goes beyond the national security community, but I think it's particularly acute in the security world, that a lot of international law, a lot of national security strategy, also military and security tactics are all based on an assumption that the natural environment is relatively static, right? That the amount of water we have in rivers is the amount we will always have, that our coastal bases and installations can be where they were placed 50 years ago, that groups in states that we care about will act a certain way based on the environmental conditions that they operate within, that countries' national interests around energy, right, will remain the same, that issues around migration, for example, and who is allowed refugee status are rooted in a certain understanding of the climate and environment and what will drive migration. But climate change, of course, is challenging all of these assumptions. It's a shaping factor or a structural force, right, that is affecting everything that the national security community cares about. And there's a big gap, I think, right now between where climate change is taking us and where the institutions and the laws and the planning structures are that we have in place in the national security community. And so filling that gap, bringing those two things closer together, I think is really important. Just to give you one really small example of this that I like to cite a lot about the assumptions, one of my first jobs, I worked in the U.S. intelligence community previously. I'm not a scientist. I'm a international security expert. I worked on terrorism issues in East Africa, and we had a lot of assumptions based on when terrorist and insurgent groups would fight in Somalia, in Kenya, based on when the rainy season was, right? And we baked that into our analysis when we were making recommendations or warning of potential insurgent offenses. The rainy season was a key part of that. Well, the rainy season doesn't exist, right, in East Africa in the same way it once did. It's much less predictable due to climate change and will become ever more so going forward. And so you have to reevaluate how you make that analysis. You can't base your analysis on previous assumptions, right? That's a very small tactical example, but there are lots of examples like that, both at the tactical and the strategic level, that will force some reckoning, I think, within the national security community. I think the other thing that's really challenging is just the higher uncertainty, right? That we're not moving to a new normal where we have a new baseline of how the environment and the climate looks, but instead there's going to be a lot more variability going forward. And I think that is extremely challenging for the national security community as well, and national security planners. I do think, you know, looking at Rod's comments, I think that under this administration, since the Biden administration took office, they have really put climate change front and center as a national security issue in a way that it hasn't been previously. And I think they've made some good strides. And one thing I would point to in particular, if you haven't looked at it already, is the new national security strategy, which was released, I don't know, 3 or 4 weeks ago now. But really, for the first time, I think it represented a step change in how the government was framing climate change as a national security threat. Instead of just one more on a list of kind of second tier human security or quote unquote soft security issues, the NSS made it very clear that climate change was right up there. These shared threats that cross borders was up there with geopolitical competition at the top of the list of the things shaping the world for the US. And I'm going to read a direct quote, actually, because I think it illustrates the primacy that it was given. So a quote from the document is, quote, "People all over the world are struggling to cope with the effects of shared challenges that cross borders, whether it's climate change, food insecurity, communicable diseases, terrorism, energy shortages, or inflation. These shared challenges are not marginal issues that are secondary to geopolitics. They are at the very core of national and international security and must be treated as such." So I think that's welcome news from the administration, welcome framing. Of course, it's one thing to put that in your national security strategy. It's another thing to really change how you do business to manage that threat. And there are a lot of changes I think we need to see throughout the national security community to be able to meet that strategic goal of treating climate change in that way. But I think it's a good step. And so I think there is progress, but I don't know that that progress is moving quickly enough, frankly, to match how quickly the climate is changing. Next slide, please. So before I get into some specific examples, I wanted to talk a little bit about risk pathways, which Rod did as well as how to think about framing climate change and national security. And I think I'll start with the second part first. Oftentimes when you approach policymakers or you approach senior folks in national security positions, you'll get questions like, well, is climate change a bigger threat than China? Or how does it compare to terrorism, right? Wanting to rack and stack or kind of number in the top 10 threats. And I think that's just those are the wrong questions, right? The questions instead are, how does climate change shape competition with China? How does climate change offer opportunities or challenges to terrorist and extremist groups? What new opportunities might Russia be able to take advantage of due to climate change, or what threats does Russia face, right? That's a way to bring the climate lens in. It's really looking at it as a systemic force or a structural force, as I said, and understanding that tackling climate change also poses opportunities for the US vis-a-vis national security, not just risks. And when I say opportunities, what I don't mean, you know, sometimes you read articles about how Canada and Russia are the two winners in the climate change world because they're going to have longer growing seasons and warmer temperatures. I think that analysis is a little oversimplified, but also that's not the kind of opportunities I'm talking about. What I'm talking about are opportunities if the US takes the lead on, say, providing climate finance to key developing countries so that they can manage the energy transition or manage the risks they're currently facing. That strengthens the US hand in building stronger partnerships abroad, in its competition with China, potentially. Like, there are a lot of opportunities there. So that's the big picture framing. Then when we think about risk pathways, and I've just got 3 buckets here, which a lot of what Rod talked about fit into these buckets, but I do want to talk about them just a little bit to help you think through how we're seeing it. The first bucket, relatively straightforward, right, is the critical infrastructure and military readiness. And these are the direct impacts of climate change on military facilities and installations. You know, things like Tyndall Air Force Base on the Gulf Coast in 2018, which was decimated by Hurricane Michael. Planes were destroyed. Every single building on the base was damaged in some way. It cost billions of dollars, right? It can also be critical economic and energy infrastructure. It can be things like military readiness, where you have wildfires in California interrupting training days for militaries there, as well as directing more soldiers to have to fight wildfires. For example, we've seen the hours that National Guard members are spending fighting fires in the US has gone up exponentially just over the past 5 years. So that's one bucket of risk. I think, frankly, that's the most straightforward bucket of risk, and also the one that the US national security community is most comfortable with and making the most progress on already, particularly for our own military. I think there are some opportunities here looking at allies and partners and their direct risks, and that the US could be doing more to help those countries manage. But I don't spend a lot of intellectual time in this bucket of risk, because I think it's pretty easy to see what needs to be done here to manage for the US military. The second and third bucket of risks, though, I think are more complex and require a lot more changes to how the US does its business in national security, and there are more opportunities here, I think, for integrated Earth observation science to help the national security community do a better job. So that second bucket, which Rod talked about a bit, are these state fragility and conflict risks, where I see generally it's not climate change alone, but it's climate change hazards layering on top in places where governments are already highly strained for a variety of reasons, right? And when you add climate change on top of that, it really can create higher risks of conflict, higher risks of fragility that could tip over into violence. You can look at Pakistan, for example, and the floods there earlier this fall, which inundated a third of the country, right? And that comes on top of, a lot of poor governance over many years, exclusive political institutions where there isn't a lot of inclusivity for certain communities within that country. You've got extremism and terrorism risks there. You also saw this 2 summers ago across the Middle East, where you had street protests in Iraq, in Lebanon, in Iran over both high energy prices and lack of water. And again, this is in part driven by climate change, because you had unprecedented droughts and high temperatures, unprecedentedly high temperatures there, but you also have, this is coming on top of poor water systems management, poor governance, again, those exclusive political institutions. There's a great book that came out this past year by Josh Busby, who's a professor down at UT Austin, called States in Nature, where he looks at that risk equation that Rod talked about earlier, and countries that experience the same climate hazards generally, but in one place, those hazards spill over into security challenges in the other places they didn't, and what were the factors that led. So that's in that state fragility and conflict risk pathway. And then the third pathway is the competition between and among states, right, where when these risks spill over across borders, and this can be things like transboundary water sharing, it can be food security issues, access to fish stocks, it can be new domains of competition like the Arctic, which I'll talk more about a little bit in a minute. It can also be over the energy transition then as well, and commitments to mitigation. You're seeing this right now at COP27 a bit, and the conversation about loss and damage and the responsibility of the high emitting countries to provide funding to lower emitters, right, who are feeling the effects of climate right now. It can create further tensions there. So
I'll interrupt you just for one. I'll interrupt you for 1 second. I see Tim Stryker. Did you have a comment, Tim?
Thank you, Anna. Yes, just noting in the chat, we're wondering, Aaron, if you're still speaking to slide 4, or were you moving ahead in your own presentation?
Nope, I am still speaking to slide 4. I don't put a lot of words on my slides, so I tend to talk a lot more than the words that are there. But
okay, no, that's great. Thanks. We just want to make sure things are matched up with you.
Yep.
Yeah, that's us scientists are incapable of having fewer than 1 slide per 30 seconds of speaking. So that's why we're making sure.
Yeah, understood. But you can move to the next. You can move to the next slide now, and then the next slide. So I did want to walk through just a few specific country examples or regional examples, because I think it helps provide more context for what I'm speaking about. And the first one here is China, and this is actually rooted in a new paper we'll have coming out at the center at the beginning of next month that really looks in depth at China's climate security vulnerabilities and then what that means for the United States. And I think it's important to look at this because the Secretary of Defense has called China the pacing threat for the US, and understanding the risks that China itself is facing will help the US better understand Chinese behavior on the world stage, I would argue. I think China's decisions around climate policy are much more driven by its understanding of its own risks, its own national interests, not whether the US is cooperating or competing with it at any moment on climate change. And it helps the US better understand, pressure points and risks. And as you may know, China, under the leadership of Xi Jinping, has adopted a very broad concept of national security that encompasses internal and external, traditional and non-traditional threats. They've got this concept of holistic national security, which was first outlined in 2014, which includes environmental security and resource security as 2 of its 11 components. China also has a very robust national climate adaptation strategy that has termed climate change an important non-traditional security factor. So it's front and center in a lot of China's planning. And China itself faces significant threats to its military and critical infrastructure. The inset map there is one map is where major Chinese shipyards are located, and then the other larger map is from Climate Central, which shows potential sea level rise, the red there, at a high warming temperature or high warming trajectory by about 2050. And you can see there's overlap there between the shipyards and the sea level rise. China also has the islands it has built in the South China Sea, the artificial islands, to try and gain military and strategic advantage there. In building those islands, they destroyed a lot of the natural protection that the coral reefs would provide. And so those islands are very vulnerable to strength and typhoons, right, to sea level rise themselves. And then China also has a lot of critical infrastructure in permafrost. It's got a railway that connects its military to the contested border with India. It has pipelines that bring energy, resources, gas and oil from Russia. Those are all in permafrost and already seeing infrastructure degradation due to the melting of that permafrost. So it has its own threats. It has its own internal political instability risks, right? Due to rising temperatures, lack of agricultural ability to continue agriculture in certain places, a lot of risks around internal migration in restive areas that China is particularly concerned about, like Tibet. That is one region that faces significant climate hazards. And then, of course, it's got its own external geopolitical competition challenges as well, again, over fish stocks and access to food, over access to resources, shared river basins. You've got 10 of the major Asian rivers originate in China. They provide fresh water to around 1/5 of the world. And as the glaciers melt, that will change those river basins' dispositions and potentially challenge further China's relationships with its neighbors. So I highlight all of this because I think it's important context for the US, and where I see a place where additional climate analysis and climate data could really play an important role for the US national security community in better understanding China itself, its behavior, persistent, continuous collection on certain aspects of China's environment and climate issues would be particularly useful and particularly needed to get things right for the US. Next slide. Another example to highlight is in Iraq, in Basra, Iraq, where it's a city of approximately 4 million people. It sits on the Shatt al-Arab River, which is created by the confluence of the Tigris and the Euphrates rivers before they empty down in the Persian Gulf, as you can see from the map there. And this is a place where you've got this combination of climate change effects, upstream infrastructure development, and poor governance practices that has led the water flow in the Tigris and Euphrates to be reduced by about 30% since the 1980s. This is an estimation by the Iraqi government. At the same time, you've got the combination of less freshwater flow, you've got sea level rise and environmental degradation, saltwater intrusion to the region increasing, so that it's all negatively impacted agriculture and fish farming. You've also had a lack of clean water in the city that's led to periodic outbreaks of waterborne disease, which has then led to the eruption of anti-government protests. So as of January 2019, a few years ago, you had about 15,000 people who had been displaced in the region due to water shortages. And we've seen these developments in Basra contributing to broader instability and political challenges in already fragile countries. Some of those that have been displaced have left the south to move to other parts of the country. They've had a lot of protests in Basra itself. There's a lot of instability there, and this is obviously a place that the U.S. has cared about and has strong national security interests for many years now. And that map there, again, is another Climate Central map, just giving you a picture of potential sea level rise in the Basra region. And I could have picked a lot of different countries to give this type of example. Basra is just one, but this type of story, right, where you have climate impacts layered on top of environmental degradation, layered on top of political instability, all coming together, is a story we're seeing a lot of places, and we'll continue to see more places going forward. Next slide, please. So this just digs a little deeper into the river basin issue that I mentioned earlier, looking particularly at the China and India border. There are really 3 points here where in the relationship with China and India, where I see climate change intersecting with existing geopolitical tensions. One is what's called the line of actual control, which is the border between China and India, which is in a very cold and inhospitable part of the world, which limits a lot of the actual military action that they're able to undertake along the border, although they still manage to fight up there on a regular basis. But as the glaciers melt, as temperatures warm, that will open that area up for more opportunity for military activity. There's also the Indus River, which is shared between the two, and China has been building dams along that river in territory claimed by India. And then there's the Brahmaputra, and also damming on that river. And what we see here is two countries with high levels of mistrust between the two, shared resources, and then climate change impacts layered on top of that, where there's a lot of opportunity for misattribution, right? For India to blame China for something downstream that could actually be the result of climate change. Both sides having different interpretations about the water levels and the rivers and who has access to what, and assumptions that both sides may have that may be undercut by a changing climate. And two nuclear armed states with a history of hot conflict along that border, climate change is just amping up the tensions there as well. The last example I'll give you, if you go to the next slide, is the Arctic, and I'll throw Russia in here as well, given the primacy of Russia and the invasion of Ukraine in the national security world right now. But when we look at the Arctic, and this map here is from a report we did earlier last year, which really is just meant to show the high levels of activity that are in the Arctic, right? As the Arctic becomes more accessible due to ice melt, you just have a lot more activity, both military activity and commercial activity. And two of the key players in the Arctic, both Russia and China, like to use commercial activity as a cover for gray zone or quasi-military activity. And as we've seen challenges with Russia and China with fishing boats in parts of the world previously, there's lots of opportunity for increased tension and risk here. And it's really, as this new domain becomes more accessible, I would argue there's a real lack of rules of the road, despite the great work of the Arctic Council over many years to pursue scientific cooperation in the region and get all parties talking. Obviously, the Arctic Council is suspended right now due to Russia's invasion of Ukraine, and it was never a good venue for security conversations in the first place. In fact, security was specifically kept out of the council to keep things peaceful. But as the security risks increase in the Arctic, there needs to be some place where these rules of the road can be discussed. So the other thing too, then I would say about Russia in this area, you know, for its history, Russia has relied on having a frozen north as a geopolitical benefit, right? It provides a natural defense to its northern border. As that ice melts, there's a strong chance that Russia feels more vulnerable in the north then, right? That becomes more accessible to a potential attack from the north. It also has the most infrastructure of any country built in permafrost around the world. That permafrost is melting. It's on fire often, and costing a lot of money in terms of economic resources, energy resources up there, but also military resources. I think it's really interesting to note that I think it was late January or early February, before the invasion, President Biden was giving public comment and encouraging Russia not to invade Ukraine. And he made an aside in the talk where he said, you know, hey, Putin, you've got a burning tundra that will never freeze again. That's your real problem. I thought it was interesting that Biden thought that was worth mentioning, or his speechwriter did. And it's true. This is a real challenge for Russia, and they face significant national security risks for themselves because of that environment. And so I think that also is really important for the U.S. national security community to understand and to follow closely how climate change and the kind of tipping points, especially that Rod mentioned earlier, I think are so important in this case, given the dynamics in the Arctic. So next slide, what does this mean? What does all of this mean for national security and Earth observation? And just a few points I thought I would highlight here, some of which tracks with what Rod has already talked about. One, I think it's really important to understand, for the scientific community to understand, that broadly in the national security community, there are low levels of scientific and data literacy. And often scientific efforts within the national security community are often siloed. This isn't to say there aren't amazing scientists and aren't amazing data scientists and natural scientists in, you know, institutions like the CIA or in the Pentagon. I mean, obviously DoD is huge and they have a ton of scientists there. But the folks, say, who are responsible for analyzing security risks in China or security risks in Central America, or a lot of the regional folks, they often, very rarely, have scientific or data literacy. And they often, you know, you might have the climate analytic office over here, but then you've got the China office or the Russia office, and they're separate. They don't intersect. You don't have climate experts in the China office, for example. So that's a real challenge. Also, there's very little standardization about what data and what information you're using. If you're your average, you know, say analyst at CIA, or if you're an analyst at AFRICOM, you know, one of the combatant commands, and you want to do some work looking at how climate change may affect a certain country or region or a certain hazard, you can, there's no standard or central repository or central, you know, data source that folks across the national security community use for that. And it's going to be your own research and what you decide to pull in, and that may be different than what somebody else is deciding to pull in and look at there. You might not even know where to go. Probably just going to the IPCC site, maybe. Depends, you know, kind of who you are and what you're doing. And so there's just a lot going on that's really varied. And I know now this, both the National Academies workshop that Apurva is leading is trying to work on this. Also the Climate Security Advisory Council, which was mentioned earlier, that I stood up before I left government, is designed to bring the scientific and the security community together but this is a long-term process. I think one of the key challenges is the bench is just really thin within the national security community of folks who look at these issues. So even though there's this great focus from the administration and putting this front and center, and DOD's done an adaptation plan, and all the services have climate plans, you got to have people to do the work, right? And that's hard. Another point is that different entities have different needs. So it really, when you're thinking through who needs what, it's going to be at different levels of detail, right? Depending on whether you're in the policy shop or you're in the combatant commands, whether you're in a military service and you're thinking about what might happen on the ground in a battle, or your military intelligence. So it's hard to kind of have a one-size-fits-all national security approach for the U.S. to what's useful. I think also when thinking about Earth observations and security, I think sometimes there's a little too much focus within the security community on acute hazards, right? What do we do now that Pakistan has had this big flood, or say there's a big typhoon? And it's a lot of disaster response kind of focus. I think there needs to be more focus, and it's more complex with some of the slow onset changes over time, land degradation, right, desertification, precipitation patterns changing over time, and what that means within a country that is already highly unstable. I think that is where a lot of attention is needed. I certainly think that continuous coverage of U.S. competitors and adversaries to both better understand some of their internal risks or what they may be doing to manage it. There's also a trust but verify potential opportunity here, both in terms of countries' commitments on emissions, but also on shared resources, right, for river basin, transboundary river sharing agreements, things along those lines where Earth observations can become very helpful. I think it's also not just trust but verify, but also an opportunity to build trust between countries that are maybe fighting or competitive. You can offer opportunities for scientific collaboration sometimes that then open broader opportunities for national security cooperation. And then the last thing is just this idea around sharing with allies and partners. Again, this is a key theme of US government right now, and our national security strategy is that our advantage in the competition with China is that we have allies and partners, right? Not only in the Indo-Pacific, but around the world. And many of those countries are facing greater climate hazards than we are right now, and don't have the capacity scientifically or institutionally to really have the right data and understanding about what's happening in their communities. And so there's a lot that the US can provide there that could be really helpful. I'm going to stop there, but I really look forward to the discussion and questions later, and thank you so much for having me.
Thank you, Erin. This was incredibly helpful and informative. I really appreciate your remarks. Our third and final speaker is Dr. Edward Carr, who is the Director and Professor of International Development, Community and Environment Department at Clark University, where he also directs the Humanitarian Response and Development Lab. Dr. Carr's research focuses on achieving meaningful and enduring improvements to human well-being at the intersection of global change and development. And he has specific expertise in climate change adaptation, resilience, livelihoods, and gender and identity. Prior to his current role, Dr. Carr served as a Science and Technology Policy Fellow for the American Association for the Advancement of Science at the U.S. Agency for International Development. And in this role, he was the first climate change coordinator for the Bureau for Democracy, Conflict, and Humanitarian Assistance, and later served as an advisor on the climate change team and the Bureau for Economic Growth, Education, and the Environment. And with that, Dr. Carr, the floor is yours. And were you sharing your screen or having us?
Yes, I will share my screen. I'm going to do that
Perfect.
right now. And hopefully you all can see, well, my slides, although not the one I wanted, but that's okay. I will get us.
We're on triggers and thresholds.
There we go. All right,
Perfect.
now we're on the right
You're all
line.
set.
Great, thank you. Thanks, everyone. Thank you for the opportunity to speak to everybody today. And as you heard from the other two speakers, the climate and security community is a small space, so it's really nice to be on with Aaron and Rod as well. I'm going to come down really dramatically in scale and try to get down maybe to the ground a little bit. And in doing so, hopefully trigger a little more conversation around the connection between, say, observations and the sorts of decision making that informs how we think about security decisions in the world. And so to do that, the first thing is I'm a first principles person when you get into difficult challenges. So we're going to back all the way up here to what is it exactly we're trying to talk about today? What is the challenge we're trying to address? And you could construct that pretty simply as how do observations inform our decision making around potential stressors and challenges in the world? However, that overlooks a really critical step that I think you heard about a couple of different times in the first two presentations, which is, in fact, when people just say observations and how they inform decision making, they're skipping a step, a really big step that most people don't talk about much. And so I like to refer to that as the black box where a miracle occurs and then observations somehow inform decision making. I think what we're talking about today, or at least what I think a really constructive conversation today would be, is to figure out what's going on inside this black box and therefore how observations can be translated into something useful in the world. So you saw this slide earlier, and so source, I stole it from Rod. Rod, I'll buy you a drink sometime, but at least I'm claiming the plagiarism here. I liked this slide because I thought it helped set up some of what I'm going to talk about. Rod, and then Aaron as well, walked us through a number of things in this slide, but I'm going to focus here because that's what I know and that's what I tend to work on as a geographer and an anthropologist. This gets to sort of what I think is an interesting point here. We heard earlier in Aaron's discussion, sort of state fragility and conflict risk points. This is where I'm going to dive in a little bit, because the climate doesn't drive conflict. That's not how this works. The climate works on existing systems, existing processes, tends to exacerbate things like inequality and vulnerability, but it doesn't directly do much of anything. And point here, I think that is really important. These systems may not have, the systems that climate works on may or may not have much to do with states. There are a large number of people in the world who technically live in states, but for whom the state means relatively little. And this includes most of the places in the world that I work. In much of sub-Saharan Africa, the agrarian populations, the people living off the land, more or less, have at best a marginal connection to the state. They don't get much from it. The state doesn't ask much of them, and they live their lives nominally within states. So when we think about, state fragility, what we're really talking about is process fragility and societal fragility that may or may not manifest at the scale of a state. Let's see here. So the other thing I think we're trying to kind of dance around a little bit here is the concept that some people talk about in terms of triggers and thresholds, right? When does an event or a trend drive some kind of new decision, new action, new behavior in the world? And there are actually fields out there that have nothing to do with conflict that have been trying to struggle with this. And they're fields that I do a little bit of work in on the social side, one of them being index insurance. For folks who are not familiar with the concept of index insurance, the idea here is to try to protect rain-fed agriculture, for example, from variations in rainfall year to year, variations that may be getting worse because of climate change, by insuring people's production and using as the device, so to speak, to trigger a payout, the amount of rainfall that comes in. Because a certain amount of rainfall below that threshold, you're expecting hits to yield, which would hurt people's incomes. And so this becomes a vehicle by which you can help people maintain their livelihoods in a changing climate. The problem with index insurance is two things. One, what is the trigger value? You've got to be able to establish what the right value for precipitation, which is usually what index insurance is about. What is the right value to then trigger a payout? You can usually work that out relatively easily scientifically if enough is known about the crop, its water needs, the local environment, etc. The other problem, and a really substantial problem in the observation side of things though, is what spatial resolution do you need to make index insurance effective? The image you see here is just a simple Google Earth capture of a village in southern Mali that I've done some work in. The red arrow you see there is where a rain gauge is located in that village. That rain gauge was capturing what is ostensibly the precipitation situation of the farmers in that village. The two green arrows you see are farms, are fields associated with farmers in that village. Each of those is a kilometer from that rain gauge. And in this part of the world, it is not at all unusual to have rain fall on one of those two arrows and not on triangles and not on the other one. Or worse, to have rain fall on one of those triangles and on the rain gauge, but not on one of those other fields, which means the rain gauge might be registering more than enough rainfall, no need for an insurance payout, while part of a village is not getting enough rainfall. So a big challenge around this is trying to figure out what scale to even get observational data to figure this out, to then trigger some kind of payout that might protect people. That's just sort of one analogous area where we're thinking about this. Another area is anticipatory action, which is a fascinating area in the humanitarian field right now, because we all know that responding before a disaster is far more effective and far more efficient than flailing away after a disaster has already happened. So the idea here is to use forecasts and observations to release humanitarian relief funds before the disaster happens. But once again, you run into problems. What's your trigger? What's your trigger value in a forecast? How certain do you have to be about a forecast before you release funds? Because all forecasts are probabilistic. There's no such thing as a 100% forecast. So exactly what is your level of probability that you need to be able to do something, to release funds before, for example, a flood hits, or to release funds before a drought becomes so severe it starts compromising crops? This takes us then into sort of defining the problem. As I said, climate variability and change work on existing systems and they work on existing structures. And anticipatory action, that example I just gave, sort of highlights this point, right? Because as it turns out, the answer to the questions around anticipatory action, such as how much certainty do you need, reflect the system within which any organization trying to implement this kind of work exists. What is the source of organizational funding? Because different sources of funding, turns out, are more tolerant of different kinds of risk. What is the organizational confidence in this funding? In other words, does the organization think it could get it wrong and still have funding show up to support its operations next year? And the last one of these is who's affected by the disaster, because the definition of a disaster in the end really counts on, do you care about the people that it's impacting? Do you care about the outcomes for them? All of these things hint at underlying systems, systems of funding, systems of international or national organizations, and the existing social systems that give people different kinds of ranks and placement in the world. So changes in variability or trend are going to get addressed differently by different organizations, and who those changes in variability or trend impact will also be treated differently by different organizations. All of this meaning that even if you're observing something, and even if we had complete agreement on the observations of what is happening in the world, how things play out on the ground can vary a lot. So what I want to do now is take you down, all the way down into a system here. I'm going to take you into an agrarian system, the decision-making that gets made, and how climate and other sorts of things mess around in that. And if you'll all indulge me for a few minutes, because I do recognize that I'm talking to a lot of people who work on the observation side of stuff here, I think you're going to have a better understanding at the other end of this as to why that black box I put up before between observations and decisions is actually a really, really hard thing to solve, but at the same time, a really important thing to be thinking about. So let's get into agrarian systems. As I said before, agrarian systems, simplest way to put this, these are people living off the natural resources on the ground, typically in agriculture, to some extent livestock, that sort of thing. There are about 700 million smallholder farms in the world right now, the vast majority of which are rain-fed, so that means that they are dependent on precipitation, which means that a changing climate impacts them rather directly. Critical point here is that agrarian livelihoods, the livelihoods of the people living in these areas, are never just about material outcomes. Yes, you're definitely trying to raise enough food to have food to eat. You're trying to raise enough food to make sure that you are materially secure, that you can pay for the things you need to, even that you might be able to invest in things in the future. But that is always balancing other things. It's balancing not just what you do, but is it done the right way? You see on this slide here, this bubble called discourses of livelihoods. Every agrarian system has ways that people in that system talk about what you should do in the world and how you should do it. That really gives legitimacy to different kinds of activities, and it also explains why in many parts of the world you can walk into 10 different villages all spread far apart and find the same people doing the exact same activities in the same way. But you'll notice there that those discourses of livelihoods also invoke identity. It's not just the right way, the right activity and the right way to conduct that activity, it's who should be conducting that activity. That tends to shape how people are seen and valued within society around these different kinds of activities. It helps shape who you are. And then on top of all that, these are kind of kept in place by what are called tools of coercion, more or less fair consequences, what people locally deem to be fair consequences for violating the expectations of what you're supposed to do, how you're supposed to do it, and who is supposed to be doing it. The takeaway from all of this for everybody here is really simple. When you start talking about an activity that someone performs in the world, you're not just talking about the activity. You're talking about gender. You're talking about history. You're talking about ethnicity. You're talking about their family. That's why transformation of agrarian systems is actually incredibly hard. That's why agricultural development is actually really, really hard. You're not just changing the crop they grow, you're changing the way someone lives in the world. So if we go into one particular set of agrarian systems, let's go into Sudanian agrarian systems, which are the geography of which is more or less highlighted on this particular map. These systems manage two categories of risk. One of them is material, the risk that you will not grow enough food to eat or to pay for the things that you need to. But the other risk is social, because that slide I showed you before creates a specific social order in the world. And that social order, like all social orders, has winners and losers in it. And the people who are winning have a vested interest in keeping that social order as it is. We see this all the time. I have tremendous amounts of data, literally over 1,000 interviews with farmers across this part of the world and others talking about their livelihoods. And one thing that we can say very, very clearly from this evidence is that beyond immediate existential material threats, as in you are going to die sometime very, very soon, the risks that environmental or other kinds of changes pose to the social order are often seen as more of a problem than the risks that are posed to the material situation. I have fantastic data, disturbing data, but fantastic data showing men and exactly how much they're compromising their wives' agricultural production to make sure their wives don't have excess income that might challenge the man's control of the household. So, we're talking about very complex systems here. We're not talking about a threshold where you say, well, if the food supply drops below this amount, people are going to behave in a certain kind of way. That's not what's happening here. You're dealing with that plus social threats, and all of that then means that responses to different kinds of stressors get extremely, extremely contextual. Let me give you just a quick example about this. One system that again, the Sudanian system here, these are two farmers in that village I showed you a minute ago from space. These are two farmers in that same village. The woman you see standing there on the left is in her field of hand-irrigated onions. She's actually standing over a hand-dug well that is 7 meters deep to groundwater, and she's standing on two pretty rickety planks. So very, very brave woman, as well as pretty industrious. She pulls water, basically groundwater, up and uses a bucket to irrigate these onions most of the year around, but definitely in the dry season. On your right, you see a man. He's standing on his rain-fed staple crop field. This is a field that's going to be containing millet when the rains start. Now, right away, when we think about these two people, this is a man and a woman, same household, producing in two very different ways. And we know there's one big environmental stress in this part of the world, a long-term reduction in the amount of rainfall that they get, at least seasonally. There's two outcomes that happen from this. One of them is reduced food availability, because the bulk of the food that comes into the household, the bulk of food that people eat, comes from the man's rain-fed field. But the other is a challenge to men's authority in this part of the world, because the definition of a good man in this part of the world is someone who feeds his whole family for the entire year with production from his field. And what you've got here is a situation where the man's production is being threatened by changes in rainfall. But unless those changes in rainfall become so severe that they compromise groundwater, the woman's production basically isn't stressed by this at all. So over time, what you can see is how this stressor would continually not only create a material stress on the household, but also a social stress within that household, because this same environmental stressor hitting both people in the household is playing out really differently there. And that kind of stressor can result in very, very low level, like when I should say small scale, domestic conflict. We see rises, for example, in domestic violence in these sorts of situations, but it can also spiral into larger breakdowns of societal organization around agriculture, including, whether or not different household units work together collectively within a family, or they atomize into smaller units. We know from data, and this is, by the way, something that's come again from observations in about a dozen livelihood zones and over 1,000 interviews and things like that. We know that there are basically two indigenous responses that we see in these agrarian systems. And by indigenous responses, I mean from the system itself, from people living within that system. If you find people who are in a materially secure situation, what happens is the rules around who is supposed to do what and what they're supposed to be doing relaxes a lot. People don't worry that much about, so to speak, deviant behavior. This is true, by the way, in the same community where you can see people who are better and worse off. The people who are better off, you see, for example, women farming things that are said to be men's crops. Whereas if you go to the worse off households, you will see no deviation at all from expectations in terms of activities and who's performing them. This works at a point in time, but it also works over time. I have a study that was done over 3 years where I can track where gender expectations changed because men thought they were going to get a bunch of non-farm employment, so they stopped worrying about how much farm land their wives were cultivating. But when men realized they weren't going to make all that extra money and that this extra farming their wives were doing was threatening men's status at the head of the household, they immediately just reshrank their wives' fields to make sure that their wives basically didn't out-earn them. So that became a very rigid response to this kind of change over time. So again, when the material is secure, you can see situations where people start to innovate. And in materially insecure situations, you can see folks doubling down on the existing strategy. This also means that people then will respond very, very differently to interventions meant to address that kind of a stressor. The material is secure, we find, generally speaking, because they're not as worried about roles, responsibilities, that sort of thing, can likely leverage these kinds of opportunities to their advantage. They can take things on. They can take advantage of, for example, programs aimed at women's production, because that's not necessarily seen as a threat to the man who's already doing a good job feeding his family. On the materially insecure side of things, though, you'll often see very, very low uptake unless that intervention is designed to reinforce not just material safety, but security of the social order. So there's a couple of implications around this. If you can understand the system that you're worried about, in this case, the human environment system that you're worried about, what's going on in that system and what its implications might be for human security, as well as maybe national security thought a little more narrowly. You can actually see crises emerging potentially. I mean, you can see them before they emerge. One of the things that comes out of all of this is a hypothesis that I've gotten into the peer-reviewed literature, but I haven't yet had a chance to test, which is that stable or really persistent systems, that is to say, if we're looking at an agricultural or agrarian system under stress and we can document that stress, but we're not seeing changes in that system in terms of what is being grown or how much land is being cultivated or who's playing what kind of a role, that's probably not good news. That's probably a highly stressed system getting more and more rigid as people double down on the existing strategy, trying to manage social risk as opposed to just material risk. Highly stressed social systems, highly stressed social ecological systems become brittle over time. They can maintain in the face of long-term change, but not forever. Adaptation isn't forever, and they're subject to collapse once you cross certain material thresholds, and those aren't necessarily very clear where those thresholds are. But let's pull this then back out to think about observations, because I've been down in the system level, so I can back my way out of this. So to think about what's going on the ground, what sorts of things do we need to know? Well, obviously you need to have a systems understanding of what you're even talking about in the first place. But after that, what do you need? Well, first, you need good observational data that gives you evidence of changes in the climate and or the local environment. Because of course, sometimes changes in the climate don't actually have a lot of biophysical meaning in terms of people's livelihoods, so they're not necessarily relevant. So we need observations and effective modeling of expected impacts or of changes or extremes possibly on, in this case, staple crop production. That's something that would tell us whether or not a system is under more or less stress over time, and therefore what kinds of behaviors we might expect to see. Then down at the bottom of this pyramid, we actually need to start looking around for evidence of systemic stress on the land. So for example, we should expect to see homogenization of crops on fields over time as people more and more rigidly play their roles and more rigidly grow the same kinds of crops. In this part of the world, we might also be looking at the atomization of landholding, in other words, collective land being subdivided up into household land, and even the dispersal of settlements. Just a side note, this is a testable hypothesis, folks, and I'm looking for partners who want to work on the observation side because my lab's already got the social data in a whole lot of places. We just need some help figuring out the observational side and whether or not we can actually see this kind of stuff from space or otherwise. So if I continue to back out from this systems of kind of view to another layer here, what do we need to actually facilitate the effective use of observational data in asking questions around human and national security? Now, some of this may sound obvious, but it's not. It's really not. We need an ongoing dialogue here. We have to connect people with understandings of the system, so the kind of stuff I know, to those with good observations of stressors or the ability to observe the different kinds of stressors. Systems people, by the way, don't always know what is observable. I am not an expert in remote sensing, in GI science, or in Earth observation more broadly. I know something about it. I've worked with people who work in this field, but I am not an expert. I'll also say, though, that most of the time when I have worked collaboratively with people who do observational work, they often have no idea what observations are valuable. I've done an enormous amount of work on weather and climate information for development, climate services. And I think I've been one of the leading people who's been pushing that field away from what we call the loading dock model of climate services, which is when a climate scientist comes up with some new information about how the climate works, announces it, basically backs a truck up to a loading dock, kicks that information off the back, and assumes that someone's going to pick it up and use it. Almost never does that work. And the reason for that is it's not clear why that information would be particularly valuable to a particular user. Effective climate services know who their users are and tailor it to them. Same thing here. Effective observations really have to do with who are you trying to inform and what are you trying to inform them of. The other thing we need is more infrastructure. Yeah, we're going to need some people, and we need specific kinds of people. We need people who are connectors, people who are linked together by shared interest, for example, in an issue, in a region, in a particular stressor. If you don't do that, if you go with people who are, say, have disciplinary foci, you're going to have a hard time getting people to work together because their incentives fly off in different kinds of directions. We need institutions, and I think of that as not necessarily capital I institutions, but lowercase I institutions, organization, basically, that results in the ownership of these kinds of processes and the staffing of collaboration processes. These are not the kind of things that get done well ad hoc. We need to have much more organization around this. Finally, we need incentives. The incentives, especially in academia, simply do not run to this kind of work a lot of the time. And actually, I don't think that necessarily runs this way outside of academia either. We need career positive reasons for connecting across boundaries. And we need to think about what those might be. I've got all kinds of ideas for that on the academic side of things that I could talk about at greater length. But as has been mentioned a couple times here, there are examples of this kind of work bubbling up a little bit, right? You've heard about this Climate Security Roundtable. I'm part of that Climate Security Roundtable. That is, in fact, checking a lot of these boxes. You've got the people, the institutions, and at least to some extent, the incentives in place. I've also been the lead author of a whole bunch of global assessments, including the most recent IPCC 6th Assessment Report. I was a lead author of Working Group 2. And in those settings, I have to tell you, it's a pretty remarkable situation because you've got people drawn together, trying to understand what's happening in the world from very different backgrounds, but they have a shared goal of better understanding the current state of knowledge around what's happening in the world, and we have institutional support, again, in all those cases to make that kind of work happen. A last point here. What else is needed? Patience, folks. We need patience. This kind of work is hard. We're talking about, and I'm going to use a big academic word here, we're talking about different epistemologies. Social scientists like me frame everything from how we even understand rigor and validity in our data differently than happens, for example, in the physical and natural sciences. That is really, really challenging stuff to overcome. It absolutely can be, but it's not easy. It takes time. Second thing, there are not any silver bullets in this space. There will be no observation that fixes all our problem, or no type of observation. Even within observations, I would argue you don't have any silver bullets. So this means that we're going to be having a lot of complicated conversations to figure out where observation fits in, how it fits in, what can we do with it, what can we advance with it. And then finally, just a simple request on all of our parts for humility here. We are way past a situation in the world where a lone genius solves any of these problems. The interesting problems around climate, human security, national security, however you want to think about it, these sorts of challenges are going to be addressed by teams because their complexity exceeds any individual's expertise. There is no way that we're going to get this done by ourselves. So that again means we're going to have to be patient with each other. We're going to have to build the kinds of institutions I'm talking about, and we're going to have to keep fostering these sorts of conversations. So those are my kind of quick comments, and I'm going to stop there and hopefully throw it back to a conversation.
Thank you, Ed. So let's just take 1 minute to thank all three of our speakers. So thank you again, Ed and Aaron and Rod. I think these were all fabulous presentations, hugely informative and fit very well together as a group as well. For the next part of the symposium, I'm going to hand things off to Tim Stryker, who will lead the discussion. But maybe just 1 second before I do so, I will toss a question at you, Tim. You can, if it fits, you can finish the discussion. But thinking about this, all this information within the context of this Keck study that many of us are participating in, one question that I had is, what are examples of situations where the need for continuity for space-based observations of parameters related to climate might be different if the idea is to support security-related questions relative to what those of us in the physical and biogeochemical sciences might think of are most needed for informing the basic science. So another way of framing it, if we design a continuity framework that optimally in some way informs the science, will that also check the boxes that the three of you see, or is this a partially complementary but partially disjoint set of requirements? And no need to do that question first, but I just thought I'd toss that out before I sign off and hand things off to Tim. So thank you all again, and Tim, the floor is yours.
Thank you, Anna, and thank you, Ron, Rod, Aaron, and Ed. That's just fabulous, just kind of mind expanding for me. I'm sure for many of our other study team members and the general audience as well. I think there's a lot for us to think about based on your presentation. Just a brief self-introduction for you and for everyone. My name is Tim Stryker, and I head up the Outreach and Collaboration Branch in the USGS National Land Imaging Program. So we're the organization that is responsible for Landsat and other terrestrial remote sensing satellite observations for the U.S. government. We work very closely with our partners, NASA, on the Landsat program, but many other external partners for other data sources. And we're part of the USGS Earth Science community that includes a lot of non-remote sensing observations. So Ed, I really thank you for pointing out the rain gauge shortage there in Africa. Knowing that satellites can't solve all the problems, in situ networks can't do it either. How do we network all these things together? And so, and what we're interested in, at least within our program, is connecting terrestrial climate data records to better monitoring and forecasting, and bringing in all sorts of data sources for better decision support. But I think what you've all done today has really been excellent in terms of showing how complex this overall process is. It's not just an in and out process, right? It's, the magic happening somewhere that you noted, Rod, and so I really compliment you all for, I guess, getting us to better, to kind of widen our aperture, so to speak, in remote sensing speak, beyond kind of traditional mindsets for climate change, just from a physical Earth system science perspective, but other elements relating to adaptation, the many other factors that work into climate change on impacting communities, and I think also moving us away from kind of a real kind of a hard national security or military doctrine approach to to security issues. And so there's so much there, and we're concerned with that at USGS also, because we kind of sit in an interesting intersection. I believe some of you may have been working with the Environmental Security Working Group for the Intelligence Committee, and that connects to our Civil Applications Committee that we chair alongside NOAA's National Geodetic Survey and U.S. Department of Agriculture. So there are a lot of intersections, I think, between kind of the civil and I guess defense remote sensing observations community. But when it comes to the challenges we're looking to address and kind of bridging observations to more effective decision making and I guess decision support, right? How can the satellite observations that NASA, NOAA, USGS, UMETSAT, many others gather, what can they do to really reduce the threats of climate change and benefit society. So we do have a number of questions that have come in. I'd like to, I'll be kind of proctoring them if you want to just send them, individually to me or to Dwayne Walliser and myself. We'll try to make sure we make the best use of the 30 minutes we have remaining. I promise I won't take up much more time talking, but I would like to ask, would like to ask the first question. And I find it really instructive. Aaron, you were talking about carbon tunnel vision and maybe, focusing so much on kind of the physical science aspects, but maybe broadening that to ecosystem services. And Rod, you had mentioned, fragility of ecosystem services and the concern kind of within the kind of the ecosystem science community about what's occurring. It seems to me certainly we need more observations of those type, in the landscape where we're all living and working and trying to manage our livelihoods, as well as many land species. But to maybe kind of carelessly borrow a well-worn phrase, from a former defense secretary, right? There are known unknowns and then unknown unknowns, and it seems like you really kind of posed a lot of kind of unknown unknowns to us in terms of what types of information kind of needs to be gathered, kind of beyond just kind of the traditional physical climate science community. What types of and how might we, I guess, as people on the study team who are looking to bridge observations to decision support, what communities do we need to engage in more frequently to better understand the totality of continued observations and data products that people will need, whether it's states or communities, to improve their livelihood and enhance climate resiliency? Does anyone want to take a shot at that question?
All right, I'll go. I just talked, so I was trying to see if anyone else is going to jump in. Probably just, I won't say much because I think it kind of comes right out of what I just said. I think observation is incredibly important. Science is incredibly important, but it needs to be anchored in a question about what you want to know about what's going on in the world. And in the end, changes in the environment are processed into meaning by people. And that's what people respond to, right? People don't respond to 10 millimeters of rain. They respond to enough rain, not enough rain, too much rain. And so understanding it at that level, but then also contextualizing that into the question, what are you trying to answer? I'm not sure. I mean, I'm certain if we spent some time, a long time probably, in conversation, there's some baseline data that probably we just should be gathering sort of everywhere in the world. But how useful is that, or what does it inform? That's probably going to vary depending on where you are, which maybe that's not the most helpful answer, but that's the one I see.
If I can just build on that too, I mean, to Ed's point that it's not 11 millimeters, is it too much or too little? Then also, if you're the analyst back in Washington, D.C., you need to know when you talk to that person on the ground, when they say it's the right amount, is that 11 millimeters, right? So there is a role, I think, for that baselining from a national security analytic perspective, that then when you marry that information with those interviews on the ground, right, that qualitative understanding, then you can make better analysis, right, of a whole lot of things going on in that community or in that country, depending. So it's really that marrying of the two together. And the thing I worry most about, frankly, is the national security community having the skills and ability to interpret and use that data correctly, right? So it's not just about the data itself, but like, how is it used? And as Ed was saying, to answer questions, but also processed and understood, right? And so that, I think there's a lot of gaps there as well.
Yeah, I think widening the aperture, beyond just physical science to the social science and kind of better community understanding and all the factors that go into that, I think is something we need to consider. But I'm sorry, Rod, you might have had something to say.
Yeah, I'll just jump in real quick, and it's really building on what Aaron said. And I was really happy to watch both Aaron's and Ed's amazing presentations. Very informative for me as well. But something that Aaron, one of the reasons why those questions are so hard for someone like me who interacted with decision makers in the White House and at the State Department, other parts of the executive branch, is that oftentimes there's not a higher level requester of this information, right? So when you ask about the gaps, well, there's one, right? I mean, so it goes along with what Aaron was talking about with the climate, I forget how you phrase it, climate literate workforce, right? There's also, we get a lot of really good language out of the cabinet, out of the national security strategy, out of, even the president of the United States on climate change and its effects on people and security. But what is missing is, that sixth floor is what we would call it in the State Department. And I shouldn't say it's missing. It's definitely not missing at the moment, but it's institutionally weak. And so you need data, you need methodology, but you need an audience. You need someone who will keep the work. You need someone to pull on this. And so I think one of the important things that the intelligence community has done over 12, 13 years has been one of those pulling functions from the academic world. But it's just so ad hoc and it's nascent. The national, the climate roundtable that Ed's a member of, that's a very nascent effort. And so the kinds of things that we're talking about are, we're so far behind where we need to be in terms of, really actualizing, turning all of the things that we've been talking about into something actionable. And just going, this leads me, to the question that Anna asked at the very beginning. Does continuity in Earth observations check the box for climate security? Well, it checks a box, right? It would be really bad for that continuity to go away. That would be, I would call this, I would have no hesitation calling this not really a national security system, which was in the chat box, but I would call it a national security asset. If you actually put national climate change in your national security strategy, and you have the President of the United States and the Congress increasingly talk about climate as a national security issue, the way that we understand the climate and its changes and its effects are through these Earth observations. It's a no-brainer. So,
yeah, well, I think that's I guess that's the box we're concerned with, right? Is the climate observations, to the extent that what we all do can help produce a more climate-oriented workforce or climate-aware kind of decision, key decision maker community. That's really important. So thank you. Well, perhaps one element here we can look at is actually a question from Brendan Byrne. It kind of connects to a broader question I have, where Brendan asked about kind of the trust but verify topic with respect to international agreements, and that Earth observations are providing a powerful tool to monitor activities in other nations. Seeing how that could be useful in verifying international agreements, although nations may find that intrusive, right? So, and there's a whole history of kind of UN Outer Space Treaty, and kind of the protocols of how governments are supposed to do that, making that data available to the censed state, so to speak. But I'd also like to add to that kind of the idea of full, free, and open data policy for civil Earth observations, which may not be something you're that keyed into, but I think in recent years, both US and Europe have made a lot of progress in doing that. So there at least is credible, objective scientific information that can be employed to not only address, a nation's problems or a community's problems, but be a confidence building measure and kind of an objective measure of comparison between those communities. And Aaron, you had spoken a lot about kind of China's policy, and I know in the prior Obama administration there was a big focus on engaging China on climate commitments. If the U.S. and China can do this together, then that can be a leadership point as well as a confidence builder. What do you say about kind of the use of objective remote sensing, full, free, and open observations? How's that viewed in the national security community? Or how can it assist the national security community? And the other thing I'd add is, this study team really, I think, fundamentally believes that continuity of civilian remote sensing and other Earth observations is truly a national security asset, from the U.S. perspective, but from other countries' perspectives as well. So.
I can jump in there to start. So, I don't know, over a year ago now, we held a conference with the Kennedy School up at Harvard on climate and intelligence, and a special envoy, John Kerry, spoke. And he spoke a little out of turn, I think. He was complaining that when he was Secretary of State and negotiating nuclear agreements with other countries, he got really good intelligence on what the other side was going to bring to the table, right? And he said in his role as climate envoy, he was not getting really good information about what the other side was going to bring to the table. And if this really is an existential threat, why isn't he getting that? And of course, there he's speaking, I think, about things other than Earth observation, right? But I think the point is similar, that, if we were talking about another security issue, right, we wouldn't hesitate to potentially use Earth observation, although in the national security and potentially classified realm, to show whether folks are living up to their commitments or not. So I think if you ask the national security community, they would say, oh, this could be useful for us. But also the challenges you raise about open data and relationships with other countries and scientific cooperation, I think all of those need to be grappled with. So I think just because we can do it for national, or there could be a national security benefit, doesn't mean it's the right path necessarily. I think that's why these conversations are so important, right? To sensitize the security community to those scientific concerns, and maybe vice versa. Yeah, I think there are different pathways or opportunities that you could think about using some of this information, especially if it is open source, to just integrate in other assessments, right? You can't stop analysts from reading open source information if they want to. But beyond that, if you're getting in, you're actually doing it using the Earth observation in a way on purpose to try and collect that information for them, that's a different question, I think. But I think you're right to raise it as a sticky wicket issue that needs to be looked at in more detail, frankly.
Okay, thanks, Aaron. Other responses
Yeah,
to?
I'll jump in. When I joined the intelligence community in 2009, this was one of the very first questions posed to me by the State Department climate team, is what is the role of the national security community, including the intelligence community, in in compliance, monitoring, verification. The thing is that Earth system, Earth observations in 2008 and in 2022 are different worlds. And quite frankly, the intelligence community and its reliance and what gives it the extra benefit of being clandestine material has changed as well. And so my own take on this, we certainly need Earth observations in support of in terms of really understanding what other countries are doing. We need that. I think having it be clandestine is a wrong move in 2022.
Well, we certainly can't bring our reconnaissance satellite observations to a climate treaty, climate treaty negotiation. There has to be a baseline of civil.
That's right. Well, and let me just echo a really common complaint from the policy world when the intelligence community gives them something really powerful and juicy. It's like, well, what am I supposed to do with this? I can't share this. And there are limitations to this kinds of information when it's clandestine.
Right. Okay.
I would also
thanks very much.
really quickly. Even if it's open source, I think it invokes something that we've heard both Aaron and Rod talk about, which is, so I'll just give you an example because I got dragged into this at the World Bank about a year and a half ago. Monitoring, reporting, verification on things like carbon sinks. There's all kinds of observations that you can use to try to do that. Most of them still have substantial error bars on them. The verification is really hard. You need on the ground stuff to calibrate. There's all kinds of challenges still around that. And even with really good observations, I'm going back to what my colleagues just said, do the people looking at that understand the limitations of the data in front of them? Do they understand what it does and doesn't actually tell them? I agree that it needs to be out in the open. I agree that it really should be something out there, but that also, I'm tempted to go to like Twitter as like things go wildly out of control all the time in that world. But and that's probably the most extreme version of stuff. But you can imagine a world where two people looking at exactly the same data come to two utterly different conclusions and start yelling at each other. And I just think that there's a capacity issue beyond just the observation that we really have to think about.
Yeah. There's a capacity building and a confidence building component to all this, right? And we need to be working with the same trusted methodology. So there are things going on. I know you're probably aware the UN Framework Convention on Climate Change, reduction of emissions from forest deforestation, degradation. Carbon sequestration, capacity measurement for tropical forested regions, and financing for preservation of those forests and things. So there are baby steps, but not a whole lot. I should get to a question from one of our leading study team members. Well, first, Aaron, I'm sorry, I misattributed a quote to you. I think it was from Rod on carbon, on carbon. But Walid Abdullati was interested in knowing, you had spoken about how the new national security strategy differs from past strategies. He used the term quadrennial defense reviews. I think those are maybe different, right? But he noted that climate change was flagged as a risk, but I guess the question was, how is the current policy being more aggressive toward climate change, and what are the impacts on the defense and intelligence community kind of analysis, decision support activities?
Sure, I can start there. I mean, so when the Biden administration took office, they issued an executive order on tackling the climate crisis at home and abroad. And that had a whole slew of requirements for the national security community writ large on climate change. It required DoD to do a threat analysis. It required the national intelligence estimate that was referenced in the beginning. It required all regional strategies for the national security community to integrate climate into their work. It required climate to be integrated into wargaming. And so that tone that was set from the very beginning, we've seen that follow through. It was in the interim national security strategy and then the new national security strategy I referenced, which comes out of the White House and the National Security Council. We also saw the National Defense Strategy, which was released just last week or 2 weeks ago, includes climate as well. And this isn't the first time, right? The Obama administration did a lot of work on climate change also. But I do think, like I said, I think it is a step change in the amount of attention, but then also when you read the NSS, it really, I think, does a nice job of showing the integration of climate beyond just one on kind of a laundry list of other things that we care about, right? And I think it is impacting, especially at DoD. I mean, like I said, each of the services, so the Air Force, the Navy, and the Army have all developed their own climate strategies. There's a climate adaptation plan. I know each of the combatant commands, each of the regional commands for the military is doing a climate war game in the next year. So there's a lot of activity. I think, like I said in my talk, it's where we're seeing the most progress is on the very tangible installation resilience and how do we make sure our military can still operate in a warmed world, more so than tackling some of these harder questions that we've all been talking about around fragility and geopolitical risk. But it's there more so than ever before, and that senior direction is really great. But as you know, Rod mentioned, you need those middle managers also pushing on it, and you need the workforce to be able to implement it and really mainstream it across. But we've got, if folks are interested in knowing what the administration is doing, we've got tons of stuff on our website and detailed reports that kind of list it all in great detail. And there's a lot there that you can dig through.
Okay, thank you. Thank you. So, boy, there are a lot of questions coming in, and we don't have enough time to cover them all. I don't know if you'd be willing to to take ones after the fact and maybe provide perspectives. I think that would be great. There were questions about let's see, questions about kind of spatial heterogeneity of rainfall, especially in the case where there is heavier soil reliance on rain gauge data. I guess the question was, and I may be butchering your question, Terrence, I'm sorry. Is this a major threat to the kinds of indexing policies that are supposed to be helping people? I mean, is there more data information that's needed by these organizations, I suppose? And what's the best way for them to get it?
So the short answer there is everyone's aware that's a huge problem, basically because we've been trying to implement index insurance. We keep crashing into it. There have been a tremendous number of efforts. I mean, the advances that we've seen from observations, even in the last decade, to try to fill the gaps on, for example, where ground stations and things are located, are quite impressive. But Tim, as you said earlier, you can't completely get away from ground stations. And so there's still a fundamental infrastructure problem in many parts of the world that is going to fundamentally compromise our understanding of what's happening biophysically. We won't have the same kinds of resolution in many parts of the world that we do, for example, in the Midwestern United States. And it'd be nice to have that, but I think that one of the questions that's out there is sort of what's a minimum resolution of data that we need to have to be effective? Again, I find myself probably answering that with an "it depends" on what you want to know and where you are. But I think that is something that probably needs to be talked through if we're going to talk about sort of observations, continuity of observations as a major issue.
Okay, thank you. Any other comments from Aaron or Rod on that topic? Okay, so another colleague of mine, Charlie Powell had a good question, and I may need a little more detail from you, Charlie, if you wish to speak up. But there's something called science traceability matrix for Earth observations, understanding, and forecasting changes, for certain types of observations, right? And it's not just, precipitation or land surface temperature, but it's some of these fundamental, maybe more kind of fundamental Earth systems measurements or reference measurements like radiation budget or mass change or, these types of observations. I guess, Charlie, you're saying that, makes a good business. What our panelists were saying was, earlier you were making out a good business case for certain types of additional land surface observations, although certainly there are more atmospheric and oceanic ones needed also. But do you have any perspective on some of the more fundamental science measurements, reference measurements for the overall Earth system, or are we getting too many steps away from the community that you're working in?
I'll just jump in. I can't speak to the on-the-ground scientific piece, but when I talk about how an ecological security research agenda is needed, this is the kind of thing that I'm talking about, where you can go from one kind of observation. Again, I make a replug to broaden the aperture to a greater number of ecosystem services beyond water provisioning and the like. But being able to traceability is a word that I wouldn't use, but I like it in this context. But a matrix, where does this impact? Let's say it's a water quality issue, or let's say an algal bloom or a shortcoming in vegetation. Where does that lead you to through all the things that Ed was talking about, which are vitally important? But can we do a fuzzy tether to societal impacts? That seems to me to be something crucially needed. And we can talk about it, in, overarching terms, but, if someone, if I were an intelligence analyst and wrote something about ecosystem services and it somehow got into the president's daily brief, and then the question, they would invariably come back, it's like, well, how does this affect whatever, people, sectors? And then we would be hard pressed to say anything more, because not only do we not understand the state of most ecosystem services, we don't know what the declines in those ecosystem services mean for societies and institutions beyond broad strokes. And if I can I make a lightning round answers to a couple of these questions in the chat?
Yeah.
Because I think I can do them really fast. One is, does the national security community rely on international data? It doesn't rely on it, but it'll take in as much information as it can. And there was a question on geoengineering. That is something that we have talked about in the national security community ever since the first week I was in the IC. It is because it often fits into these narratives that are easy, right? A malign actor or an actor of some sort doing something, I think there's a hard scientific piece there, in terms of to what degree will it work, and and some other ethical issues. But rest assured, climate engineering is in the national security discussion, whether it's out in the open or not.
It was in the NIE, I think, as part of the conversation there for sure. So
yeah, I guess it's hard when the malign actors are like all of humanity contributing to a drastically changing climate and its impacts on all of us, right? So Yeah,
It's also not just malign actors, right? I mean, it could actually be states acting in what they feel is their best interest, and not intentionally screwing things up. But you can imagine various scenarios in various parts of the world, because in the IPCC, where we got very, very anxious, is just the uncertainties around it. You're tinkering with a complex system, and the outcomes of that are just indeterminate. And what does that mean? Okay, fine, you cooled thing. We know you can cool the atmosphere with particulates. I mean, volcanoes demonstrate that to us all the time. But what do you do? What does that mean if you do that regionally? And what are the knock-on effects? And unlike a volcano where people can be unhappy about it, but you don't blame the volcano. Like, if something bad happens and you got a state you can blame, then what happens there, especially if that state actually gets the outcome it wants and doesn't want to stop doing it. I mean, that's where I think things get really hairy. It's not some malign actor somewhere. It's people being forced to act in their own self-interest, because actually, Tim, as you were saying, we've utterly failed to stop warming from getting to where it is to this point.
Well, being a tragedy of the commons, and I think, Aaron, you pointed that out also, right? That it's really going to upend, national security planning kind of writ large, right? And honestly, from a civil agency perspective, it seemed to me, at least over the past 6 years, that kind of the defense and intel community was kind of ahead of the civil agencies on planning scenarios and kind of decision support. But I've really learned a lot today that there are a lot of challenges everywhere, right? So one question came up, I think connected to, this from CJ Ebinger on, how do security analysts plan to connect to early warning systems already deployed and planned as per Special Envoy for Climate Kerry's announcements at COP27? For example, if we have indicators of poor crops in Zambia and Botswana in 2023, do we have plans in place, or should we? And I might add to that, I think one of you had spoken earlier about, I think it was you, Aaron, you're talking about opportunities for U.S. leadership, in climate change resiliency, right? So are there things that, would the U.S., share more objective science data, to kind of make the case of a coming tragedy? Should we take a leadership in, kind of financing support, prior to a major famine? What levers might the U.S. government have based on objective data and information? Or are we even able to exercise it, given kind of the difficult state of, the sixth floor, I guess you would say, right, for the U.S. government?
I actually am pretty optimistic on the early warning systems and the government's ability to integrate that into some planning. I think you look at FuseNet, which has been for famine early warning for many years, which has been, I think, used pretty successfully. I think, we'll see what these new warning systems look like, how they're deployed. I'm sure folks at USAID and state are already thinking about it in quite a bit of depth. You listen to USAID leaders and they say that they're a climate agency now, right? So, this is right in their wheelhouse. I think when you step over to, say, the intelligence community or DoD and how they might use those warnings, it's a little bit different question, right? Because they're probably not going to be doing the response, maybe DoD if it gets very bad. But the intelligence community integrating that into their analysis and warning is a different question, I think. But I think there are more opportunities there than they have traditionally taken in the past. Certainly, better integration into the regional analysis piece. But I know AFRICOM, for example, the Africa Command is thinking quite a bit about this and their work on the continent for the military, and really wanting to have better collaboration. One of these challenges is to make sure that we're using all arms of government together in these challenges so that AFRICOM and USAID and state are all on the same sheet of music and we're using the right parts of the government for the right answers. But I'm curious to see how these early warning systems develop. Sorry, the last thing I'll say here is I think one of the challenges we've seen with early warning systems is you can get the technical warning correct, but then people don't act on it for reasons that aren't related to the technical warning. They're related to, do they trust the government, right? Who are the communicators? You saw this with Hurricane Ian in Florida, where communities were warned and they didn't leave. You saw it in Germany with the flooding a couple summers ago. That happened there. You've seen it in China. So, so it's a problem overall, and that's, I think, the harder question sometimes. and one that if I were in the Intel community still, I would be interested in exploring and thinking about, so that you could think in the future which countries might be more vulnerable than others.
And the totality of human nature and communities is.
And I would just, all that I agree with, and those are great comments. I would also say, just to foot stomp on what Aaron was saying, early warning is not enough if you don't have early decision, right? And the signal to noise ratio at times is, even really good early warning still, yeah. And by the way, we have really good early warning on pandemic forecasting, but it didn't result in a lot of early action, right? We had a lot of scenarios, a lot of things with coronavirus in mind, but yet a lot of that was not acted upon. So it can't just stop at early warning.
And in 2011, to Aaron's point about FuseNet, because I was sitting in the bureau where this happened, we knew the Horn of Africa famine was coming 6 months out. We knew it was coming. If FuseNet had called it, it became more and more apparent. And to Rod's point, you need early decisions. And everyone stared at an incoming famine until it ran us over like a truck. And then we all reactively responded as if we didn't have FuseNet. So I think that there is something critical on the other side of this that has to be done. And there's nothing the observation community can do about that except to be aware of it. And again, I think talking about those conversations and that infrastructure to pull people together to address the kinds of things that lead to people not making those decisions.
Well, it's kind of a microcosm of, the fact that it seems like we're much better at disaster response than disaster preparedness. And, climate change is a major, existing, slow moving disaster. So I apologize. There were so many good questions here. Haven't got a chance to ask them. Perhaps if you all would be interested in receiving them, in writing and responding for the study team, that would be great. I don't want to run us past our 2:30 deadline because I want to be respectful of everybody's schedule. So I'll turn it back over to Dwayne, Betsy, Tapio. Anna, thank you very much for kicking us off. Anything the four of you, Anna, Dwayne, Betsy, Tapio, would like to say in conclusion?
I'd like to just make, first of all, thank everyone, including the organizers, but particularly the speakers, and also make the plea that if anyone participating in this call or related to this topic wants to send either of us, Dwayne, Tapio, or myself, messages with respect to how we can assure that this effort, this KISS effort, is going to be more useful, please, we want to hear that. If there are topics that need to be covered, documents we should be aware of, we welcome that. And additionally, once this study is complete, we would like to be able to brief interested parties and see about what is the next stage from here. Once we've developed a framework for talking about continuity of observations, how can we most support this community as we go forward?
I just want to say thank you. These were hugely informative discussions, some going beyond the scope of what we can do, but I think definitely informing what we have to do. And I found it very helpful. Thank you.
I'll just say I'm happy about the chance to maybe keep this conversation going and now having people sort of on the other side of the aisle, so to speak, in a different way. And it's nice that we can maybe forge a partnership along the lines of our common objectives here. You guys did great. All the speakers, and Tim, thank you.
Okay. Any closing remarks, Anna?
Not beyond just saying thank you again to everyone who participated, all the questions in the chat, all the speakers, and then Dwayne, Betsy, and Tapio, and Tim as well. And I'm not sure if we could close out there, or Tim, you may have some final remarks based on the discussion as well.
Just, thank you again, everyone. It was really just a wonderful afternoon or morning for some of you. I think we'll capture hopefully the questions asked, and maybe we can try to chew on them a little bit more. Unless response if they're willing. So thank you very much.
And thanks, Wingsy, for putting this together logistically. You did awesome. It's turned out perfect.
Thank you. Thank you all.
Thank you very much.
Thank you.
Thanks, everybody.
Thanks, everyone.